Okay, now let's see how to evaluate logarithms. Remember that the way that we evaluate or read or understand what a logarithm is that logarithm is an exponent. That is, a logarithm answers the following questions. The following question: b to what power gives me y? So let's solve some examples. In this case, I have log base 2 of 4. How do I solve this? Answering the question 2 to what power gives me 4. And the answer is 2, meaning that the result for this logarithm is 2. The answer of a logarithm is a power. Now, 7 to what power gives me 49? The answer again is 2. The answer of the logarithm is the power at which you have to raise the base to obtain this value. Now, 4 to what power gives me 64? 4 to the power of 3 gives me 64, meaning that this answer is 3. In this exercise, 3 to what power gives me 89? The answer is 3 to the power of 4 is 81, meaning that my answer is the exponent. This example, 1/5 to what power gives me 1/25? The answer is 2. If I raise this fraction to the power of 2, my answer is 1/25. So this logarithm is 2. Now, what happens here? Notice that my base is bigger than the argument of my function, but these two numbers are related. Why? Because you know that the square root of 81 is 9. And by the properties of exponents, you know that a square root can also be rewritten as the power 1/2, meaning that the answer for this logarithm is 1/2. In this example, 25 to what power gives you 5? Again, notice that your base is bigger than your argument, and you know that the square root of 25 is 5, meaning that the exponent at which you have to raise 25 to obtain 5 is 1/2. Why? Because the square root is the same as the power 1/2. In this example, 81 to what power gives me 1/9? My tip to solve this type of exercises is to do it by steps. First of all, you know that there is a relationship between 81 and 9. By now, you know that relationship is that the square root of 81 is 9. That means that 81 to the power of 1/2 is 9. But also, you know by the exponent properties that if the exponent is negative, then your answer can be reciprocal, meaning that if this exponent is negative, I can obtain 1/9. So the answer for this exercise is 1/2 negative. Next example, 25 to what power gives me 1/5? Again, let's do it by steps. First off, let's see 25 and 5 what relationship they have. You know that the square root of 25 is 5, meaning that 25 to the power of 1/2 is 5. But I want 1/5, meaning that my exponent should be negative. So the answer for this logarithm is 1/2. In this example, 2 to what power gives me 64? The answer is 6. 2 to the power of 6 is 64. So this logarithm is 6. Logarithm base 64 of 2, how much is it? Notice that if you already know that 2 to the power of 6 is 64, that means that the sixth root of 64 has to be 2. Another way to think about this is the following. You know that 2 to the power of 6 is 64, but you want to isolate 2. So what operation do you have to apply to isolate the 2? You have to raise everything to the inverse power that you already have. If your power is 6, the reciprocal is 1/6. In that way, we have 2 equals 64 to the power of 1/6. So the answer of this logarithm is 1/6. Now, look at this example. We have the logarithm base 64 of 1/2. If we already know that the logarithm base 64 of 2 is 1/6, that means that you know that 64 to the power of 1/6 is 2. But I don't want 2, I want 1/2. That means that my exponent should be negative. So the answer for this logarithm is minus 1/2. Now for this exercise, 27 to what power gives you 3? You have to remember that the cubic root of 27 is 3. So the answer for this is 3. Remember, another way to look at it is to go backwards. That is, I know that 3 to the power of 3 is 27. But I want to isolate 3. So I have to apply the inverse operation. The inverse operation for this power is the reciprocal power 1/3. So that if I distribute this power, I have 3 equals 27 to the power of 3. That means that 1/3 is the correct answer for this logarithm. Now, this exercise, 1/4 to what power gives me 16? First of all, you know that if you raise this fraction to the power of 2, this is 1/16. But if you want to flip it over, you only have to transform your exponent into negative. So this is minus 2. Here again, 1/49 and 7 have a relationship. You know that 49 is the square root of 7. But if you apply the square root to 1/49, or square root of 49, this would be minus 1/7. But you want 7, meaning that your exponent should be negative. So this equals 1/2 negative. And those are the most complex evaluations you will see.